Hello everyone, this is Dr. Lennon, and we are going to be doing section 11.2 today, Quadratic Equations. We went over that last class before we went on the virtual learning switch over, and not everyone could make it, so I just wanted to go over those again because we hadn't posted any of the homework, but now that's available. So let's go back through 11.2 one more time, and we will pick up with fresh material next week. So 11.2 is Quadratic Equations. So basically, a quadratic equation is one that has the form ax squared plus bx plus c equals 0. This is known as the standard form of that quadratic equation. We'll see some questions that ask us to put a quadratic equation in that form. So this is where a, b, and c are real numbers. And that's pretty much it. So x is your variable, a, b, and c are real numbers. So we've got lots of different examples. We can ask some basic questions. Is something a quadratic equation or not would be the most basic. So is it a quadratic equation? We'll look at a few examples here and we'll see what can cause that to work and what can cause that to fail. The first of those things, let's say we have 15x squared plus 9 equals 0. So this would be a yes. We don't have a middle term there, a so-called bx term, but that's all right because that just we could always rewrite this if we wanted to as, say, 15x squared plus 0 times x plus 9 equals 0, and that would fit the description. So this is a yes. B, let's suppose we have 10x plus 3. This would be a no because we do need an x squared term. So up here I actually should make some specification. So not only are a, b, and c real numbers, we need to say that a is not, additionally, a cannot be 0. So a is the only parameter that can't be 0. We need to have some non-zero degree 2 term for it to be a quadratic. So we require a x squared term with a non-zero coefficient. C, let's say, I don't know, 5x squared plus 17x equals 11. This is just a yes. We could rewrite as say, we could subtract 11 on both sides over here, so we could say minus 11, and then this would look like 5x squared plus 17x minus 11 equals 0, and that would fit the bill. And maybe we'll look at one more example, say something like 8 minus the square root of x equals 0. So this is a no. It's important to keep in mind that if you have radicals, this is because I would say the square root of x is x to the 1/2 power, and fractional exponent of x are not allowed. Similarly, you could also have division by a power of x, and that would be equivalent to writing x with a negative exponent, so that's also not allowed. So let's look at, I mean, we kind of hinted at it here, but writing in standard form, that's all it amounts to, is putting all the terms on one side and getting 0 on the other. So example, we'll say we want to try to write these things in standard form. So write in standard form. So I don't know, let's say we have x squared minus 15x equals 7. So we just saw this with another example. So we can subtract 7 on both sides and go ahead and write this as x squared minus 15x minus 7 equals 0. Maybe we could also look at another one where, I don't know, maybe we have something like, let's say x times 15x minus 9 equals 5x squared. So a little more work to be done here, but basically the idea is we just want to expand on the left-hand side using the distributive law and then move everybody to one side. And again, it's actually your choice which side you want to move the terms. There's no correct side. You could move all the terms to the right-hand side and keep 0 on the left, or move all the terms to the left-hand side and keep 0 on the right. We just need to make sure everybody's on one side of the equation. So if we distribute here, x times 15x would be 15x squared, x times 9 would be minus 9x, and we still have the 5x squared on the other side. So now that we've expanded on the left-hand side, our last remaining job is to just subtract 5x squared here. So we can subtract 5x squared. And the like terms, we just subtract the coefficients. So we end up with 10x squared minus 9x on the left and 0 on the right-hand side. So that's it for writing in standard form. Pretty simple. In class, we discussed factoring to solve these types of quadratic equations, but in the textbook, for our purposes, since we're doing technical math, we really only care about numbers used for measurements. So we're kind of only going to appeal to 2 techniques. So the first thing that we'll look at is what's known as the square root property. So the square root property is pretty straightforward. It allows us to solve a bunch of special quadratics. So basically what the square root property says, it says if k is some non-negative number, then the equation x squared equals k has solutions x equals plus and minus the square root of k. So there's 2 solutions there, and they're pretty easy to work out. Again, if you aren't so good at taking square roots in your head, you can always appeal to your calculator. And if you're good at factoring, you can use this trick along with completing the square to essentially come up with a quadratic formula. But for our purposes, we're just going to use the quadratic formula later. And I'll also show you how you can use graphing technique to solve these types of equations using Desmos. Okay, so let's look at some examples where we solve these things. So we'll say solve, and I'll specify for this one using the square root property. So let's say we have, I don't know, something simple like x squared equals 49. Well, in this case, k is just that number 49. So we can just write down the next step is x equals plus or minus the square root of 49. So for our purposes, that means x is plus or minus 7, because 7 squared is 49. So, you know, a lot of times in set builder notation, we'll just list out the numbers in increasing order, -7, 7 between braces. So I believe for the online homework, it requires that notation. So a lot of times you won't want to type in x equals. You're just going to list the numbers in order. Let's look at another one. Maybe 36x squared equals 625. So this requires one more step. So the first part is to just isolate that x squared. So before taking square roots, although you can take square roots first, but I think it's a little bit simpler to just divide by the 36 to get the x squared alone. So we have, okay, x squared is this 625 over 36. And so by the square root property, we can say x is equal to plus or minus the square root of 625 over 36. And the square root of 625 is 25. And the square root of 36 is 6. So this is just plus or minus 25 over 6. So we could say our solution set is minus 25 over 6, comma, positive 25 over 6. And those are the two solutions. All right, so maybe I'll show you. Let's look at one more example just in case you actually are curious kind of how this can combine with factoring. I know we haven't talked too much about factoring unless you were in class the last time before we went to digital online learning. So let's say we happen to have something like, I don't know, x squared plus 10x plus 25 equals, let's say, 81. Now, the left-hand side of this basically can factor as x plus 5 times x plus 5. Right? You can check that by just looking at FOIL. X times x gives x squared. The outside terms give 5x. The inside terms give 5x. So 5x plus 5x gives your 10x up here. And 5 times 5 gives the 25. So really, this is written as x plus 5 quantity squared equals 81. So we can actually use the square root principle on this equation because we have a perfect square now on the left-hand side. So what the square root principle would say is really we have x plus 5 is equal to plus or minus the square root of 81. And so x plus 5 is equal to plus or minus 9. And then that kind of branches into two equations that we can have. We could have x plus 5 is minus 9, or we could have x plus 5 is equal to positive 9. And then we could solve each equation to get both of our two solutions. So both equations are solved by just subtracting 5 on each side. So we have x is minus 14, or x is 4. So we could write our solution set over here if we wanted as minus 14, comma 4. So that would be the solution set there. Pretty nice. We can see how this combines, and really if you take another class in algebra, they might show you how you can use this trick known as completing the square to kind of always represent the kind of a quadratic equation in this way. So that's where the quadratic equation essentially comes from. But I don't want to spend too much time on that part of things before we for this class. So we're just going to go ahead and state the quadratic formula as if it's fact and kind of work on the arithmetic. So let's look at the quadratic formula. So the quadratic formula basically tells you if you write your equation in standard form, that is, so the solutions to, so the standard form looks like ax squared plus bx plus c equals 0 are, okay, so here's the big quadratic equation. Again, since we're doing online learning, you really don't have to memorize this. You can always look it up, but the more you work with it, the more it'll kind of stick in your brain. So our x equals negative b plus or minus the square root of b squared minus 4ac, with everyone being divided by 2a. So it's important to recognize that the entire quantity is being divided by 2a, not just the square root. That's a common mistake. Okay, so there's a special part of this equation. So if you look at this thing below the radical, b squared minus 4ac is called the discriminant. And what it does is it tells us actually what kind of solutions we have. So there's three possibilities. So if b squared minus 4ac comes out to 0, then the equation has one real solution. If b squared minus 4ac is any positive quantity, then the equation has two real solutions. And 3, if b squared minus 4ac is less than 0, the equation has no real solutions. There are, in fact, it has two imaginary solutions. But we are not dealing with imaginary numbers in this course. We're just studying real valued functions. So for our purposes, we can say it has no solutions. Although if you work with complex numbers, you will have two solutions in that field. Okay, so really this formula is not so, well, it might look complicated, but really that's all we need to do is plug in and simplify. Most of the equations on the homework are just going to require that you give a decimal answer rounded to 2 or 3 places, something like that. So we just need to make sure that we do the arithmetic. So when doing the arithmetic, like normally there's a couple of problems that students run into. So if b happens to be a negative number, negative b will come out to be a positive number. So this thing in front, this first term, is not necessarily always going to end up a negative. And if b is a negative number also here in the b squared, we need to put that in parentheses, because remember there is a difference between if we include parentheses or not. So let's just recall the difference. So let me see, do I have an eraser up here? I don't know where that one is, but anyway. So yeah, let's recall. So let me just scratch that out. Recall. There's a difference between something like -5 squared versus -5 squared. -5 with parentheses actually means -5 times -5, which comes out to positive 25, whereas on the right hand side, remember the negative denotes really a multiplication, so the exponent would be applied to the 5 first, so this would come out to -25. So if you're not including the parentheses and say you're typing it into your calculator, you're going to get something completely incorrect. So we need to keep in mind to include parentheses if b happens to be a negative number. So let's look at some examples where we solve by quadratic formula. So solve by quadratic formula. So let's suppose our equation looks something like 11x equals 18 minus x squared. So again, remember, you can't start applying the quadratic formula. And let me remind you the quadratic formula just over here, so we don't have to keep going back and forth between different pages. So -b plus or minus square root of b squared minus 4ac, everybody divided by 2a. So for this one, we can't start using this formula until we're written in standard form. So what I'm going to do is I'm going to move both terms on the right-hand side to the left-hand side. So that can be accomplished by, well, what do I have to do to the right-hand side to move things? I need to take away 18, but add x squared. So I do that over here, minus 18 plus x squared, and again, so 0 is going to be on the right hand side, and I always like to write my terms in order from largest power of x to smallest power of x. So this would be rewritten as x squared plus 11x minus 18. Okay, so now that we are in standard form, we can identify what our letters in the formula are going to be. A is 1 because it's just x squared, so that implies 1 is the number in front. B is the number in front of x, which is 11. And C is the constant term, which is minus 18. So now we can apply the quadratic formula. So we just need to plug those things in. So in this case, we end up with x is minus 11 plus or minus the square root of b squared. B is a positive, so we don't have to worry about anything here. 11 squared minus 4 times the 1 times the minus 18, with everyone being divided by 2 times a. So this would simplify to negative 11 plus or minus the square root of 121 plus 72 over 2. So that comes out to negative 11 plus or minus the square root of 193 over 2. So again, we can write that in set builder notation as negative 11 minus the square root of 193 over 2, comma, negative 11 plus the square root of 193 over 2. And you can use your calculator to get some decimal approximations, which is typically the way I think they're asking for the answer. So let's see. Gets negative 12.45 if I round to 2 places, and the other value is going to be 1.45. So those would be your 2 values there. Okay, so again, it's a little lengthy, but really it's mostly just identifying A, B, and C, and then going ahead and simplifying your arithmetic. So let's continue on. So maybe 3 more examples here, and then we'll move on to some word problems. So B, let's look at, maybe we even have some decimals, 0.3x squared plus 0.5x minus 0.7 equals 0. So again, here A is going to be 0.3, B is 0.5, and C is minus 0.7. So our solution here will be x equals minus 0.5 plus or minus the square root of 0.5 squared minus 4 times 0.3 times minus 0.7. Let's extend that square root over here. Everybody being divided by 2 times 0.3. So this is negative 0.5 plus or minus the square root. Let's go ahead and calculate that number. 0.5 squared minus 0.4, or excuse me, minus 4 times 0.3 times negative 0.7 is 1.09. So we've got 1.09 underneath the square root, and then 0.6 on the bottom. So if we want to approximate those, basically our 2 values here I'm being a little sloppy using set builder notation from an equation form, but just trying to save a little space. So we get negative 2.57. And the other one would be negative 2.57 or 0.91 I'm getting my other solution for. So now maybe is a good time to show you how could we check some of these. So we can use some graphing tools on the internet to go directly to the answer if we want. So let's keep this equation in mind, 0.3 x squared plus 0.5x minus 0.7. Let's do this graphically. So let's go ahead and open up a web page. So Desmos.com, Desmos.com is a very nice graphing utility. And basically a quadratic equation in standard form is just the graph of a parabola, and it's asking where are the x-intercepts. So rather than typing in 0 equals that equation, instead we can just type in y equals 0.3 x squared plus 0.5x minus 0.7. And we can just look at the values where it hits the x-axis, and those x values, negative 2.57 and positive 0.91, those are exactly the two values we got computing this by hand using the quadratic formula. So you can always check your answer very quickly by graphing the parabola, so set it equal to y equals, and then just looking for where it crosses the x-axis. So that's something to keep in mind anytime you're solving a quadratic equation. That's an easy way to check if you have access to a computer. Okay, so let's go ahead and continue with some more examples here. So let's see. Let's look at C here. Now let's say we have x squared minus x minus 33 equals 0. So again, we can identify our values. So A here is 1, B is minus 1, and C is minus 33. So then we can go ahead again. So this is a little bit different because B is now negative 1. So when we apply the quadratic formula, negative B would now be positive 1 because the two negatives would make the negative a positive. So we end up with now 1 plus or minus the square root. And as mentioned earlier, since B is negative 1, we need to put it inside parentheses when we square it inside the square root there. And then we do minus 4 times 1 times negative 33. You can really omit the 1 whenever you're multiplying that because it doesn't do anything. Same on the bottom, 2 times A, which is 2 times 1, so that just comes out to 2 in the denominator. So this we can write as 1 plus or minus the square root. What are we getting there? We're getting 1 plus 132, so I think we're getting 133 divided by 2. So that's what we end up with there. And again, we can approximate both those in our calculator to get both the solutions. Let's see what that comes out to. So negative 5.27 or the second value here is 6.27. All right. And one last example just to see one last case with the discriminant. So say we have x squared minus 2x plus 3 equals 0. Here we have A is 1, B is -2 and c is 3, then well, what happens? We have x is, again, now it's going to be +2, plus or minus the square root of b squared, so that's -2 in parentheses squared, minus 4 times 1 times 3, with everybody being divided by 2 times 1. And now watch what happens. We have x equals 2 plus or minus the square root of -8. We get 4 minus 12 underneath the square root. And so for our purposes, we can just say this has no real solutions. So this falls into that third case where our discriminant came out to be a negative number. The number underneath the square root came out to be -8. So we can go ahead and say that there's no solutions there. Again, that can be solved over complex numbers, but we're not going to worry about that. All right, so let's just go over two kind of word problems that arise. So let's look at this first example. A lot of times you can get these quadratic equations arising out of area formulas because they are in square units. So this first example, we have the length of a rectangle is 2 times longer than the width. So what we want to do is find the dimensions that given area of 162 square inches. So what we can do is we can draw a picture here. You know, we can draw some kind of rectangle, and we know the width is maybe x and the length is 2x, and we know we get the area of a rectangle by just doing length times width. So this becomes a quadratic equation because we know the area is 162 and our length is 2x and our width is x. So our equation here is 162 equals 2x squared. So this can be solved using the square root principle that we started off with. So we divide by 2. We get 81 equals x squared. So then we know plus or minus the square root of 81 is equal to x. So x is plus or minus 9. We know for a application problem involving distance, only positive values make sense. So that basically means our width is x, which is 9 inches, and our length is 2x, which would have to be double that, so that would be 18 inches. So these would be our dimensions that would give that area of 162 square inches. All right, so one more kind of application problem here. So example, let's suppose we have, we want to find the radius of a pipe whose cross-section, I think that's hyphenated, has an area of 24 inches squared. So basically the cross-section on some, circular pipe, got, the pipe here, the cross-section is just this part. So we're looking at the area of a circle. So the area of a circle is given by the formula pi r squared. And again, this can be done using, we know our area is 24. So we can go ahead and use the square root principle to solve this. Again, you can approximate pi by about 3.14, but the earlier that you try to use an approximation, then the more error prone you're going to be. So I'm going to just leave it as pi for now, divide by pi on both sides. So I get 24 over pi is x squared, and then using the square root principle, I get plus or minus the square root of 24 over pi is equal to x. And again, because, I switched from r to x, but remember this is really the radius, so for some reason I changed the letters I was using. So let's go ahead and just leave that. So really it's the radius. I'll just write out the word. Again, it only makes sense to have a positive radius here since we're talking measurement. So that value is going to be about, typing it into the calculator here, about 2.76, and again we're using inches. Alright, so that's it for that problem.